Welcome to another deep dive.
Yeah.
Today, we're looking at something pretty interesting. What happens when really smart people, like geniuses,
Yeah.
encounter something totally new?
Yeah, like a big discovery that just flips their world upside down, or maybe a culture that's so different it has its own logic.
Yeah, or even trying to, explain something really complicated that they understand to someone else.
Right, and sometimes that other person is also a genius, which makes it even more interesting.
It really gives you a glimpse into how, intellectual exchange works.
Exactly. We often think about, scientific progress as this straight line.
Yeah.
Like just facts piling up one after another,
Right.
discovered by super rational people. But if you really zoom in, you start to see a much more, human story.
Yeah, more dynamic.
Yeah.
Yeah.
Full of unexpected connections and leaps of faith, and sometimes even really smart people just hit a wall when it comes to understanding.
Totally. And to get to the bottom of this, we're going deep into Richard Holmes's The Age of Wonder.
Great book.
Yeah, this book really paints a picture of Britain in the late 18th and early 19th centuries.
Like a time when science was just exploding.
Exactly, a total scientific revolution. And Holmes does a fantastic job of bringing the people behind these discoveries to life.
Yeah, he shows you their personalities, like their quirks and how they interacted with each other and the big changes their work caused in society.
Right, and what makes this era so good for our topic is that Holmes includes all these personal accounts, like letters, diaries, notes scribbled down right in the middle of a discovery.
Right there in the moment.
Yeah, so we can almost see in real time how these incredible minds wrestled with completely new information and then how they tried to explain what they understood, often to people who were still trying to catch up.
Yeah, still wrapping their head around it.
Exactly. So our mission today is to uncover those specific moments where brilliant people found themselves in that position.
Mm-hmm.
Yeah, sometimes it's awkward, sometimes it's exhilarating. Yeah. Trying to understand something totally new or having to explain their groundbreaking ideas to others, maybe even to other geniuses.
Right.
And for you, the listener, who we know loves to get right to the heart of things.
To the good stuff.
Yeah, exactly. These stories will give you some real insight into how knowledge is created and shared.
Especially when genius is involved.
Okay, so let's jump right in. Let's start with Joseph Banks on the Endeavour expedition.
Perfect place to start.
Yeah, so what's really important here is the main scientific goal of that whole voyage.
Observing the transit of Venus in Tahiti in 1769.
Right, a huge deal for calculating something called the solar parallax.
Yeah, basically figuring out the distance between the Earth and the Sun.
And there was a lot of pressure because the next chance to see this wouldn't happen for over 100 years.
Not until 1874.
Right, so no pressure.
Right.
So into this really high-stakes scientific adventure comes Joseph Banks.
Yeah, now Banks was quite a character, wasn't he?
Yeah, definitely. He came from a really privileged background.
Super well educated.
Oh, yeah. And he had this confidence and social grace that was totally different from the more reserved Captain Cook.
Yeah, it's interesting. Cook, especially when he interacted with the Tahitians, he kept things pretty formal.
Yeah.
But Banks, he was all about enthusiasm.
Yeah.
And really engaging with them openly.
Right. And it seems like this kind of odd pairing actually worked really well.
Yeah. Cook's super meticulous approach to charting and navigation
Right.
was a perfect match for Banks's curiosity.
Yeah, he was curious about everything.
Yeah, and that amazing ability he had to connect with people who were completely different from him.
Totally different backgrounds,
Yeah.
totally different ways of life. And Banks really threw himself into understanding Tahitian culture.
Oh, yeah. It wasn't just about writing down all the exotic plants and animals he saw.
Yeah, he went way beyond that.
He really connected with the people, built trust, and he made these incredibly detailed observations about everything.
Yeah, their clothes, their cooking, their religious beliefs, the art of tattooing.
You could almost say he was like a pioneer of modern anthropology right there on the spot.
Yeah, who was way ahead of his time. And what's remarkable is how willing he was to completely immerse himself.
Yeah, he lived among them, slept in their homes, ate their food, worked hard to learn their language.
He wasn't just some detached European observer.
No, he was an active participant in their society.
Yeah, and his journals are full of these incredibly detailed and honest accounts of Tahitian life.
Things that other Europeans might have missed or just thought were unimportant.
Or just dismissed, yeah.
And the details he recorded about their social structures, especially their family and kinship systems,
Yeah.
those were really important early insights that challenged the European ideas about hierarchy
Right.
and suggested that, hey, maybe there are other ways to organize a society.
It's like he was saying there's not just one right way to do things, and it all leads up to this key moment where Banks tries to explain to the Tahitian king Taroa and his people why they were really there.
To observe the transit of Venus.
Yeah, can you imagine trying to explain this abstract astronomical concept to someone whose whole worldview is probably structured so differently?
It really shows you just how hard cross-cultural communication can be.
Especially when you're trying to get across complex scientific ideas.
Yeah, ideas that depend on a shared understanding of the universe and math.
Right, and the accounts suggest that Banks did his best. He actually showed them Venus as it seemed across the sun.
He really tried to make the purpose of their long journey clear.
Yeah, he wanted them to understand. But think about it. The whole idea of solar parallax depends on watching the same event.
Venus crossing the sun.
Right, from two different places on Earth.
And that tiny difference in how it looks from each spot lets scientists figure out the distance.
It's kind of like holding your finger out in front of you and closing one eye and then the other.
Yeah, your finger seems to jump a little.
Right. So explaining this triangulation to King Taroa,
Mm.
I mean, that must have been incredibly difficult.
Yeah, it's mind-boggling.
And what happens next is just so telling. Immediately after this big astronomical demonstration, the conversation shifts to something much more down to earth.
Buying a hog.
Yeah, and the arrival of some Tahitian girls.
It really shows you how different their priorities were.
If they understood the world.
Yeah, Banks is talking about this grand cosmic event.
Right.
But in that moment, it probably meant a lot less to them than what was happening in their everyday lives.
Okay, let's move from the beaches of Tahiti to something a little more well-grounded. The world of William Herschel and his homemade observatories.
Sounds good.
This is a guy who started out as a musician.
And through his own curiosity and teaching himself, he became one of the most important astronomers of his time.
Yeah, his journey is truly inspiring, especially when we think about this idea of explaining things to geniuses.
He didn't come from like a typical science background, you know?
Yeah, he was self-made.
His passion for figuring out the universe was something he developed on his own.
And the fact that he built his own telescopes and they got more and more powerful.
That tells you everything you need to know about how dedicated he was.
Yeah, and early on, he wasn't afraid to go out on a limb with some pretty wild theories.
Yeah, he was a bit of a risk taker.
Yeah, I'm thinking about those papers he sent to the Bath Philosophical Society.
Especially the one where he said there were forests and even people living on the moon.
Yeah, that must have caused quite a stir.
Oh, definitely people were talking.
Yeah, and while those early ideas seem a little out there to us now,
A little crazy.
yeah, they actually show the spirit of exploration back then, and importantly, how little they actually knew about the universe.
They were working with very limited information.
Right, Herschel was pushing the boundaries of what was known.
Even if some of his ideas turned out to be wrong.
Yeah, and his theory, even though it was incorrect, it highlights something really important about early science.
How they relied on making connections and comparisons with very little data.
Right, because they only knew one world.
Earth.
Yeah, so they applied what they knew about Earth to other planets and stars.
It was a way to make the unknown seem a little more familiar.
Yeah, to make sense of it. And we absolutely can't forget the huge role played by his sister, Caroline Herschel.
Oh, she was amazing.
Her dedication as William's assistant was just incredible.
She spent countless hours making really careful observations.
Often in really difficult and uncomfortable conditions.
Yeah, like freezing cold nights.
Yeah.
And Caroline's contributions are often overlooked, but they were massive.
Yeah, they were essential.
Can you imagine spending all night in the dark and cold, methodically scanning the sky?
Yeah, searching for these faint little points of light.
Yeah, and all the while carefully writing down everything William was seeing.
It was physically demanding and sometimes dangerous, too.
Yeah, absolutely. And she went on to discover several comets on her own.
Yeah.
And she got recognition from the scientific community.
Right.
She even got her work published in Philosophical Transactions.
That's a big deal.
Huge, especially for a woman in science at that time.
Okay, and then there's the sheer audacity of Herschel's 40-foot telescope.
Oh, yeah, that thing was a monster.
The scale of it is just mind-blowing.
The engineering challenges, the cost, the fact that it basically became a tourist attraction.
Yeah, people came from all over to see it.
Even John Adams, the future president of the U.S.,
Yeah, think about that.
he went there, talked to Herschel about the possibility of aliens.
It just shows you how intellectually charged the times were.
People were hungry for knowledge.
They wanted to know what was out there, and the way they observed the stars was fascinating too.
Yeah, William would be up high by the eyepiece shouting out what he saw.
And Carolyn down below, freezing her butt off, writing it all down.
Yeah, it was a well-oiled machine,
Yeah.
fueled by their shared passion for uncovering the secrets of the universe.
Okay, so let's come back down to Earth.
Okay.
Literally. And talk about a development that was just as revolutionary ballooning. But early on, there was a lot of skepticism about these contractions.
Especially from the Royal Society.
Yeah, those guys were tough critics. And even Joseph Banks had his doubts.
Yeah, Banks always the practical one.
Yeah, he wanted to see some real benefits to society or science.
Not just amusement for the masses.
Yeah, he was representing that careful, evidence-based approach.
Yeah, very characteristic of the scientific establishment back then.
But then you have someone like Benjamin Franklin, always thinking ahead.
Yeah, always looking to the future.
He immediately saw the potential for balloons to lead to new discoveries in natural philosophy.
Yeah, he compared it to those early experiments with magnetism and electricity.
Which seemed kind of strange at the time.
But turned out to be groundbreaking.
Exactly. And Franklin was right.
He had that vision.
He knew that what seems like a silly experiment can sometimes lead to huge breakthroughs.
Totally unpredictable.
And then, boom, you have the Montgolfier's first successful manned hot air balloon flight in Paris.
Ballomania.
Yeah, everyone went crazy for balloons.
Huge crowds. It was a real spectacle.
A total sensation, and the Montgolfiers were smart.
They combined science.
The idea that hot air rises.
Yeah, because it's less dense than cold air.
Right.
With a real talent for showmanship.
Yeah, they knew how to put on a show, and that public spectacle was key to getting people excited about this new technology and about science in general.
Exactly. It captured the imagination.
And then we have Lunardi's first manned balloon flight in England, another massive public event.
Yeah, and he actually tried to talk to the people on the ground.
Shouting through a speaking trumpet.
Yeah, even throwing down letters he'd written.
The people watching must have been in awe.
And maybe a little terrified, too?
Yeah, a mix of emotions for sure. And Lunardi understood the power of a good show.
He knew how to play to the crowd.
Even if his attempts at communication didn't really give us any scientific data.
They definitely made the balloon a symbol of human daring.
And progress.
Yeah, pushing the boundaries.
But it wasn't all just for show.
No, some people were really interested in the science.
Right, like Dr. Jeffries.
Yeah, he did a lot of balloon flights with Blanchard.
And they were focused on gathering information.
Taking instruments up to measure the atmosphere and collecting air samples for Henry Cavendish.
Yeah, Jeffries was really pushing ballooning as a tool for science.
Not just entertainment.
Yeah, and trying to explain the science behind these measurements to a public who were mostly just amazed by the fact that people could fly.
That must have been quite a challenge.
Okay, now let's dive into the world of chemistry.
All right.
With Humphrey Davy, a true rock star of science.
He rose through the ranks fast.
Yeah, he was brilliant, charismatic, driven, and he loved to learn.
From a young age.
And he really made a name for himself with his groundbreaking experiments, especially with nitrous oxide.
Yeah, laughing gas.
And what's interesting is that he didn't just observe these experiments from a distance.
No, he was right in there experiencing them himself.
Carefully documenting the effects, even trying to capture the feeling in poetry.
It's like he was blurring the lines between the scientist and the subject of the experiment.
Totally. And his lectures at the Royal Institution were legendary.
Especially the one called Historical View of the Progress of Chemistry.
Where he took all this complex information and presented this really compelling picture of a European scientific community working together.
Yeah, all trying to understand the world better.
And he'd throw in these unexpected asides, like suggesting that Cleopatra might have been a chemist.
He had a real knack for making science not just understandable, but really engaging.
Yeah, his lectures were big events.
Social events, intellectual events.
Yeah, with demonstrations and his own infectious enthusiasm.
He really brought science to life.
And by showing the history of scientific progress.
He created this sense of a shared intellectual journey.
That went beyond national borders.
It was bigger than just one country.
And, of course, there's his invention of the safety lamp for miners.
A life-saving invention that made a huge difference.
Yeah, and what's really interesting is that he decided not to patent it.
He could have made a fortune.
I know, but he didn't.
He was driven by a sense of duty to the public.
Yeah, he wanted to make miners' lives safer.
And the science behind it was brilliant.
Preventing the ignition of flammable gases like fire damp, which is basically methane.
Right. A really dangerous gas found in coal mines.
His invention saved countless lives.
Yeah, it was a game changer.
But his decision not to patent it led to some controversy.
People challenged his claim to be the sole inventor.
Yeah, they said others had contributed too.
And it's worth noting that Joseph Banks stepped in to defend Davy.
Even though he'd been skeptical of some scientific pursuits in the past.
He really believed in Davy's work.
Yeah, and this whole debate about the safety lamp.
It shows you how complicated and sometimes messy the issue of scientific credit can be.
Who gets the recognition?
Yeah, and Banks was a powerful figure in the scientific world.
Yeah, he used his influence to support Davy.
He knew Davy deserved the credit.
Okay, and then there's Davy's later work with copper sheathing for ships.
Trying to stop barnacles from growing on them.
Yeah, which is a huge problem back then.
Slowed the ships down.
And at first, everyone was really excited about this idea.
But it didn't work as well as they hoped.
Yeah, it actually led to more seaweed and other stuff attaching to the ships.
It's a good reminder that even the best scientific ideas can run into problems in the real world.
Yeah, things are often more complex than we think.
Nature always has surprises.
Okay, finally, let's talk about Samuel Taylor Coleridge,
A literary giant.
who was actually pretty close to Davy early in his career.
Yeah, and Coleridge's view on how we understand science.
It offers a really interesting alternative to that purely observation-based approach.
He brought a different perspective.
Yeah, Coleridge was all about the power of imagination, deep feeling intuition.
He saw the pursuit of knowledge through a different lens.
And his interactions with Davy and his later writings about scientific inquiry, they highlight that ongoing conversation between science and art.
Two different ways of looking at the world.
And his quote about 500 Sir Isaac Newtons not being equal to a single Shakespeare or Milton.
That really got people talking.
Yeah, it sparked a lot of debate.
And it suggests that he believed in the unique power of human emotion and intuition.
Yeah, that there are some truths that you can't get to just through logic and scientific methods.
He's saying that art and literature can reveal things that science can't.
Exactly. And the fact that people are still talking about that quote today.
It shows that there's this constant tension between these different ways of knowing.
But they're both valuable.
Absolutely.
Okay, so to wrap up our deep dive, we've looked at all these examples of brilliant minds wrestling with new ideas.
And the challenge of explaining them even to other really smart people.
We saw Banks trying to communicate science across cultures.
Herschel trying to convince the scientific community about his radical astronomical discoveries.
The struggles to explain and use revolutionary technologies like ballooning and Davy's inventions.
And Coleridge's deep thoughts on the very nature of understanding.
And what's clear from all of this
Is that even the most brilliant people face obstacles when they encounter something new.
trying to really understand something new and explain it to others.
Dealing with practical limitations, reconciling new information with what we already know.
These are all part of the process of intellectual growth.
And observation, experimentation, collaboration, and even intuition.
They all play a crucial role in advancing our understanding of the world.
It's a team effort.
It really makes you think, doesn't it?
About your own experiences.
Think about a time when you tried to explain something you really understood to someone else.
Or when someone tried to explain something complex to you.
What made it easier or harder to understand?
How did logic, observation, and imagination all work together?
It's a constant back and forth, this search for knowledge.
And we hope our deep dive today has given you some new ways to think about this amazing human endeavor.
Thanks for listening.
See you next time.